one person do. And one person has been a big influence on me has actually been the Dalai Lama. And he said, if you think one little individual can't make a difference, try sleeping in a room with a mosquito. And I decided I'm going to be a mosquito.
Yay!
And that's what I am, and proud of it.
Yeah, good.
So, the other thing I just want to say too, yeah, I actually get to work all over the world. I was in Italy last week, a few weeks before that Africa, so on, in Mexico. Now we're allowed to travel again. I hop on the first plane out of Australia when I could. So, look, I rarely get invited to speak in Australia. And when Lisa asked me, I jumped at the opportunity. I love this area. And more importantly to me is what you are doing here is more than, it's being the mosquito again. It is so important to, how can you say, we're fighting a war against one of the biggest extinction events on our planet, climate change. We talk about all the chemicals, all the problems they're causing, so on and so on, But the best way to win the war is to make their systems irrelevant and develop our own. And that's what's happening here. The power of community, the power of networking, the power of saving some of the most important biodiversity on this planet, and that is the biodiversity we eat. Yes, we've got to save our endemic and native biodiversity. That is really important. But as a species, even equally important, we need to save the incredible biodiversity of hundreds of thousands of types of plants and foods, and also all the different types of animals that we use in our production. They've all got roles, and we're losing them. This is the biggest extinction event on the planet, what we call the farmer land races. These seeds and breeds that we, as a species, have developed on every continent over millennia. And it's all being replaced. Our food now is being reduced to 5 species of plants and a handful of, a couple of species of animals. And that is a system that fails. And the classic one at the moment is a war in Ukraine, and Africa is starving because we've got our system wrong. It's all about, exporting food, growing food for exporting, and the poor people buy it. Well, it doesn't work that way. As soon as you have a disruption in the exports, you get famine. And there's been famine in large parts of Africa now since COVID has started, but it doesn't make the news. Things like Donald Trump is far more important for our daily COVID figures, and more important than thousands of people dying in Ethiopia, Sudan. Before colonialism, countries like Ethiopia fed themselves very well. They were major exporters. No one starved. And the current famines on this planet aren't due to have me say we're not growing enough food in Ukraine to export to them. It's because we fundamentally changed the way societies work, that the first market is the kitchen table, and we work out from there. And when we go and relocalise food, we bring back resilience. So everywhere that localised food in this pandemic, they thrive. Organic markets, when we start looking at local levels, did so well because the supermarket shelves were empty. And so I basically want to say that what we're doing here is essential for us as a species. And I want to say too is that you might think you're a little group, but this is a global network on pretty well every country, on every continent. You're part of one of the biggest revolutions. And we just keep it nice and quiet and keep it going. And I suppose what I really want to say is that the real important thing here is local democracy. The best democracy, the best power is at local level, because we can all participate and all be involved, and that's what's happening here. So that's, for me, is a really important driver for me to come here, just to let you know you're not alone, and what you're doing is just so important on a planetary level, not just for Cooktown. 51 years ago in Kuranda, when I first went to Marjorie Spears' place.
Oh yeah.
And I was 17 at the time, and we were walking in there and just being absolutely blown away with the flowers, the vegetables, all tropical fruits, seeing jackfruits for the first time, and custard apples. And I thought I'd landed in the Garden of Eden.
Yeah.
From that point onwards, I knew what I wanted to do. So, what I'm doing now is a little bit different than that. I'm the international director of an organisation called Regeneration International, which set that up. The group of us got the list of the organic international leaders like Dr. Vandana Shiva, myself, Ronnie Cummings from the Organic Consumers Association in the USA, and others. In New York, we're meeting in the Rodale headquarters when they had this climate change meeting in 2014, and we decided to do something about it and set it up. And as a result now, you'll hear the word regenerative agriculture everywhere. We've actually changed the global dialogue on agriculture and how to change agriculture for the better. We now have over 400 partner organisations in over 70 countries. That's pretty good for an idea that started in 2014 and wasn't formalised until 2015, and we're growing all the time. Before that, I was the Vice President and President of ifoam Organics International. That's the global umbrella body for the organic movement. And it was out of that. I stepped down in 2017 to concentrate on Regeneration International, because I felt we could actually move and have a much bigger effect on agriculture as a whole, which is what we're doing. So I'll go back to who I really am. What most of my life is, I'm a farmer. And I'm a farmer who just loves growing plants. And so these are sort of pictures of my farm. Part of it is what I've grown, and the other part of it is what we've regenerated in terms of 2/3 of my farm now is really good rainforest flower on a family farm, so my wife and I raised our children on it. But I just love the fact that we have waterfalls, we have cassowaries on the farm, and Victoria riflebirds, we have platypus in the creek. So all these things weren't there before we came. And bringing back what I call keystone species, showing, that to me is my biggest vote of confidence that the animals have come back and we're restoring biodiversity. But I also love, different exotic plants. I probably have one of the best collections of bamboos, tropical bamboos in Australia, in the world, over 100 species. I think bamboos are one of the most important plants. Then, there's a whole range of others. As Lisa said, one of my areas of expertise are water lilies. I'm a world expert on Australian water lilies and being involved in discovering new species of water lilies in Australia. So for me, that's a hobby. But that also gave me someone who left school without finished school and ended up with a doctorate of science because of that. And so I just love the idea of endemic biodiversity, but also bringing on other forms of biodiversity around the house with gardens. I get so much pleasure of having a garden and plants. And then the other side of it is growing food, particularly tropical fruits. That's my, or how we raised our family and everything. I used to be at the point where we exported all around the world. Grew tons and tons and tons. Started, first person to bring back things like champadeks into Australia. There's only ever a few durians and mangosteens and rambutans. I went over to Asia and, brought back the first commercial quantities to actually start this industry.
Yay, thanks for that.
So, and what I really want to talk about now is how you do it. When I started doing this, I was told everything I was doing was impossible. Firstly, when I wanted to get the fruits, people said, I can't do that. You can't bring them in Australia, it's impossible. So I went and saw what was AQUIS in those days, the quarantine authorities. I found out it wasn't impossible, it was just very, very difficult. Now, very, very difficult means that you could solve it. So once I'd solved it and did it and proved it was possible, then that opened the floodgates and everybody started going over it and bringing back. And we started a whole new industry in far north Queensland. I was also told, because at the time before I went over to Asia, the best collection of these tropical fruits was actually in a hothouse in the CSIRO laboratory in Adelaide, growing indoors. I said, how come we don't have these in far north Queensland? And they said, well, if we can't acclimatise you to growing the Murray-Darling, it's a waste of time, you're too far away from markets, don't bother about it. So I was told I was too far away to sell them. And of course, once I started growing them, it's impossible to grow them organically. I always tell my children, never let anybody tell you that things are impossible because you grew up in an impossible farm. So we did grow them organically and we exported all around the planet. We grew the quality and the quantity. So I want to talk about that too. And the most important one is this word, soil health. We were ridiculed over it. Marjorie Spears, and then I was a member in the early 70s of the Healthy Soil Society, and we were regarded as the nutcases. When, all you needed the soil for was to hold the plants up so they didn't fall over, and as long as you threw enough chemicals in, the way it would go. That was the idea. But we persisted with this idea, and last week I'm on a scientific advisory committee for the European Union for all their work on soil health, and this is 27 countries. So I'm over there in Europe because now soil health is really important in Europe, and the government's putting billions into it now. And same in the USA, they've just done it. Not quite the same here, unfortunately. But but it's changing. Actually, Terrain, before I drove up here yesterday morning, Terrain, the NRM group, will be doing a soil health conference for FNQ in June 4, 5 and 6 next year in Cairns. So it's changing. It's been a long time, but it's changing. But where it's really important, it is the key to growing successfully is getting the soil right. You get down to basics, that solves most of your problems. Because most pests and diseases are opportunistic. They attack plants for their stress. So if we balance the soil, we get minimal pests and diseases. And what we want them to be is rich and beneficial organisms, nutrients that have good structure. So I want to start with something, because one of the things you realise is that industrial agriculture has the cart before the horse. It's got things wrong. This is, unfortunately a bit small and blurry, but this is in America. This is actually in pounds per acre, but pounds per acre and kilos per hectare are almost identical. So if you look at an average soil, sandy loam has got 1,300 340 kilos per hectare. The silt loam, 3,618 per hectare. A clay loam, which happens to be a lot of our soils here, 6,432 kilos, or 6 tonnes of nitrogen. So then another really important, phosphorus. You know, we're looking at 4,000 400. No, 400 exactly on a sandy soil. So, but when you start getting the loams and clays, it goes right up. The same with potash, you know. And so you're starting to look at tonnes and tonnes. Why, so we just go to the average here, if we've got 3.5 tonnes of nitrogen in the soil, why do we need to buy urea? If we have 5 tonnes of phosphorus, maybe with 400 you need to think about it, 400 kilos, 5 tonnes of phosphorus, why are we going to bother about looking at potassium, 35,000 tonnes? 35 tonnes with 35,000 kilos. Why are we buying it if it's already there? And oh, sorry, yeah, I should have realised. But you actually see the numbers there so much better now. I've put these as the major nutrients, but you know, the average soil has thousands of kilograms of mineral nutrients, and yet we're told we need to go and buy them. Why? Well, the standard answer goes, oh, these minerals aren't in the form that plants can take up. You know, so what you need to do is buy water soluble. Spend a lot of money. At the moment, farmers are complaining because once again, war in Ukraine has meant that the price of nitrogen has got skyrocketed. Farmers can't afford it. You know, you've got to buy it. But what I want to talk about, and when we talk about a concept of regeneration now, is working with nature to regenerate our systems. Why not do what nature does best? We use biology to make them available. And so we change our science away from chemical science to ecological, biological science and apply that to make this incredible reserve of minerals available to us for nothing. Or just by changing our practices, I should say. So let's talk about how we do it. We'll talk about the most important events that ever happened on our planet, and it's photosynthesis. We get solar energy, the main greenhouse gas we have on the planet, we combine it with water, and the leaves make the most important molecule on our planet. It's called glucose. And glucose is the basis of the food system of life. So it's a basic sugar. You know, all the sports drinks, that's what they have. It's a glucose. They have a hit of glucose. It's mostly what our mitochondria in our body use to develop our energy in our cells. There are also ketones, which are these basic fats that can be made out of glucose that also our body will use, that are made in our liver. And when we fast, our body uses these ketones, and ketones actually a much better nutrient. You get less, how do you say, when they burn you get less of the free radicals. But you know, so if you combine glucose together, we can get sugar, things like sucrose, sugarcane, sugar, or lactose, milk sugar, fructose, fruit sugar, so on, dextrose, honey sugar. And these are all glucose put together in different ways. And then this is long chains, cellulose, which is wood, long chains of glucose joined together. And what things like termites can do, that have microorganisms in their body, in their gut, they can eat this and turn it back into glucose and water. It's why termites are so successful in the dry areas. They don't need to drink. They turn this into because they're sugar, energy source, it's all the water they need. But really importantly, when we talk about nature, because they're recycling all this, not a lot of things can eat wood, but a lot of things in nature can eat termites. And also what is left over from the termites now is the most important part of biology to feed those ecosystems, because they recycle it. The only thing about termites is we're not too happy when they recycle our houses. But the other thing with glucose, we can actually, plants will modify by actually adding a bit of hydrogen to it. It's called carbohydrate. That's our starches. Rice, wheat, taro, bananas. Or we can modify it slightly again. It's called a hydrocarbon. That's oils and fats. All the oil we have in our car, diesel, comes from fossilised photosynthesis. That's through this process. And the other one, which is really important in this process, these molecules, if you add a bit of nitrogen, sometimes a bit of sulfur, we make amino acids. That's our DNA, our proteins, our saliva, our hormones, our skin. But it all comes from this one fundamental building block of life, glucose. And from there, plants, other organisms, including us, will synthesize all these other molecules of life. That's why I use the word, I like the word molecules of life. But when a plant grows, when it photosynthesizes, while it grows, around 30% of these carbon compounds, these molecules of life, are secreted through the roots into the soil to feed what we call the soil microbiome, or the soil life, the soil food web. And we call it the lipid carbon pathway, that's what Christine Jones calls it, or Elaine Ingham will call it the carbon gift. But that feeds, the technical term, it's over 100 years old, but only now has it been taken seriously. So what I want to explain here, this is a root tip, and you see these exudates coming out of it. That, as it grows, these exudates come out. These are all these molecules of life that feed the soil microbiome. And so around here, you'll find all the microorganisms living. It's actually the area with the highest biodiversity on the planet. A teaspoon of this soil will contain more species than all the above ground species in the greater Daintree. To put things in perspective of what this level of biodiversity is and how important it is. It is the basis of all life on this planet. This photosynthesis, feeding the soil and building the soil. So here's a picture here. That's the root. And what you're seeing here, these are things like fungal hyphae, and see how the soil, the peds of soil, good soil has these little balls that are called peds that break apart, and you see how it's holding it around the root there. And these bits of mycelium from the fungus are going out, but you'll also see there'll be all these different sorts of bacteria. Some will fix nitrogen, some will fix glucose, other ones will repel pests and diseases. There's multiple benefits that these do to keep the plant healthy. I'll just talk about some of them. And this is I love this one, the little pine seedling. Mm-hmm. That's its roots. And what we see here, all the white, are the threads of the fungi, the mycelium. And what they're doing is the equivalent of extending the roots of this little pine tree for miles and miles and miles if you add all the mycelium together. And these mycelium now are getting the phosphorus, the nitrogen, the water, and bringing it in to these areas where they're doing what we call the exchange. And what they're exchanging it for is the molecules of life, the glucose and other organic compounds, the food that they need, because they're underground, they can't photosynthesize, they can't make glucose. they have to get it from other sources. So in this case, we call this synergy in nature. And I want to get rid of this Darwinian concept of survival of the fittest. That's what we're taught out there is. No, it's not. That is synergy. They're talking to each other. They're communicating. They're working with nature. You know, if survival of the fittest was true, there'd only be the biggest, one species of the biggest tree there because they would have outcompeted and killed everything else. But the more you leave that, the more species over the years will come in. That's synergy. You've got to get rid of this idea of, any plant is not our crop as a weed and it's competing with it. If we put the right plants in, we can put more and more and more in the system and improve the system. The higher the biodiversity is, the more productive the system is. That out there is more productive than the cleared areas because it's now trapping the light at every level, getting every photon of energy, photosynthesizing it, and those roots are now putting 30% of everything they're doing into the soil to feed the soil microbiome and increase. So the more leaf area we can get, the more energy, the more of these molecules to feed the soil microbiome, and the more productive our system is. We're using solar energy. What people aren't taught is that it's this process that builds soil. We're told, soil comes from the weathering of the rocks. Mm-hmm. And it used to puzzle me, because I was good at geology, but it puzzled me when I dig down really deep and you get down to where the bedrocks are, and I think, how does weather get down there? Mm-hmm. I'll say, look, sometimes, it's frost and stuff that break rocks. We don't get frost here. It's water. I go, well, there's no water, there's no wind, there's no weather down there, yet the rocks are weathering because these mine the rocks, they break it apart, they actually then turn it into soil, give it structure. It's the biology, it's the fact that the roots get deep down, putting these sugars and carbohydrates and proteins and all these things that feed the microbiome, and the microbiome now is pulling the minerals out of the rocks to give to the plants that are feeding them the food, and as they pull the minerals out, the rocks fall apart. That's what's happening, and that is how soil is built. It's a biological process, soil aggregation, and really importantly, it's a biological process that is mediated by roots. And so the key, what I want to say here is, this system is fed by solar energy. And the solar energy collectors are the most efficient on the planet. We call them leaves. You have to be able to do better than them. Mm-hmm. Even though you've got scientists now trying to think if they genetically modify plants, are going to make it better. We'll see about that. But I suppose what I really want to get across here is that soil creation is a process of biology. It starts with the leaves capturing, using sunlight, capturing carbon dioxide out of the atmosphere, water from the ground, making all these sugars, feeding the microbiome, who now, creates available nutrients, will actually turn rocks into soil, that's what they say. And that's how soil is made. So, this is the one I want to talk about now. Plants correctly managed increase the biodiversity, increase the soil nutrient levels. So let's look at this. Because what's happened is we've been taught for too long that anything that's not our crop is a weed because it's competing with it. So you've got to get rid of weeds. So we nuke them, we spray them out, we till them out, we do all this sort of stuff to kill out anything that is not our crop or plant that we want. So Let's look at the science. And this to me, I just want to explain now. Everybody thinks, oh, plants feed from their roots, that's why we have to fertilise them. You know, you give them liquid fertilisers because plants feed from their roots. Actually, when you look at a plant like this, 98% of what you see comes from carbon dioxide and water. And the energy to put it together is solar energy. 2%. Some cases, some plants, maybe 5% will come from minerals from the soil. The bulk of that, what we see there, is like this is glucose and water. Most of that is glucose and water. You know. But what we're seeing out there, 95 to 98% of everything there comes from water and carbon dioxide put together with solar energy. So what we're not taught is managing the 98%. We worry about 2%. 2 to 5% come from the soil. And it is important to manage that 2 to 5%, don't get me wrong. But when we ignore the 98%, we've got the cart before the horse. We've got it upside down, we've got it wrong. So let's have a look at what's happening in this picture. These leaves are photosynthesizing and are building big long roots. They feed the roots with the molecules of life. Now, 2%, maybe 5% they've got from the soil. If we cut the leaves, what happens now is we're starving the roots. And what in this case plants will do is shed excess roots because they no longer have enough food for them, so they've got to put themselves back in balance, because if they can't, it doesn't make much sense to starve all your roots, because if you do that you die. Plants aren't stupid. Plant scientists might be, but plants aren't. I've learned it. So what they do is they put themselves, if you cut them off, they shed the roots off, they'll keep enough just to feed the leaves. As the leaves grow then, they will grow more roots and they'll go up. Now we can use that as the basis for understanding how we can work with more plants in our system and how we can work in agriculture, food growing with our crops. So I want to get across two really important concepts, and you'll be hearing them more and more. The crop that we sell, or we eat, or we trade, or we just want to look at, because it's a nice flower, we like the beauty of it, we'll call that our cash crop. And what we want to make sure is that it has primary access to sunlight and water. It gets it first. And then we have another crop we call the cover crop. And the cover crop we grow to feed the soil microbiome, to feed the fertility and produce nutrients for the cash crop. What we're doing in agriculture is by having bare soil underneath our cash crop, we're wasting all this solar energy that could be feeding our plants. Consequently, the way to feed it is you have to buy all these chemicals. Bare soil does not photosynthesize. Neither do dead plants. We need live plants. But what we do, we've done enough contrast, but what I want to show you here, because we want them to get the solar energy, we want their heads to be up and that they get it first, okay? Our cash crop, the plant that our primary one, it needs to be taller than our cover crop. So it gets the solar energy. And what it isn't using, because they won't use it all, can go down and feed our cover crop. Similarly, if we cut the leaves of our cover crop down, it'll drop its roots. So it won't be competing so much for water and nutrients, like I showed you before with that plant. By keeping it, just mowing underneath it, okay? Or just slashing it down with a machete, whatever. But keeping them down means that they shed their roots. Also, by doing that, when they that basically, I suppose one of the best ways to explain it is this. When you go and cut this right off, and that body of roots now gets shed, the microorganisms feed on that, make it available to our cash crop. In other words, by cutting this, this now feeds the crop we want to grow, not the other way around. We actually turn the best way to say it is we turn the crop we want to grow into the weed, but the thing we used to call a weed that we now call a cover crop. I actually hate the word weeds. I don't use it anymore. I only have cover crops, and we manage them. So, because our cash crop now is higher, its roots are lower, it's down in the subsoil where the water is. It's getting the water. It's got longer and bigger roots. It's getting the minerals. So it's management here. It's not eradication and destruction. You've got to get over this idea that we need to nuke anything that we don't want. And start working out how to work with nature to turn to our advantage. At the moment, well, that's not quite, that's an older picture, but over the wet season I let what I call my cover crop grow, which is guinea grass and a whole range of legumes, and all my neighbours think are weeds. I put my tractor in there so you can actually see how tall I let it get in my orchard. My neighbours just can't believe I'd let my orchard go to rack and ruin like this. Most atrocious farmer. But just think about that. The amount of, organic matter I have, the amount that, basically that has now gone into the soil. But actually, the best way to conceptualise this is whatever is above, the root is about usually much the same below. There are differences. And sometimes the root is more, sometimes it's less, but we generally say whatever is above is the same below. And the same again is shed by the roots. So in the soil I have 2/3 of this. 1/3 is roots, the other third are those exudates that you saw. And then when I either slash this down now, that rots down and feeds my cash crop, which in the case here is rambutan trees. And, so that I'm building soil fertility. That's a phenomenal amount of organic matter that goes in to feed the soil microbiome. In other words, turn weeds into cover crops to feed the cash crop. Use them to your advantage. Use timing. No point going out in the middle of the wet season trying to knock this down. I actually want to use every drop of rain and every photon of sunlight on my place to grow my fertility. Bring in biodiversity. This is good science. So, an example, we'll talk about the science now. Let's talk about what I did in my first 11 years. I had less than 1% organic matter. I raised it up to 6%. My pH was 4.5, which is not very good. That's just below neutral. That to me is beautiful. For most of the crops we've got, we want it to be just slightly acidic. And this is for me a really important one. It's called total exchange capacity. What that means is it's like a fuel tank for nutrients when you grow your crop. The smaller, if you think of it as a fuel tank in a car, if you've got one and you take 2 litres, you're not going to get very far. You've got to refill it. You can take 100 litres, you can go a long way. So here, in other words, what I've done is more than tripled the capacity of my soil to hold nutrients to feed my crop. And then, nitrogen. This is a nice level for me. With fruit, I wouldn't want more than that because what happens, and you see it happen very often to people, you put the extra nitrogen on the fruit trees, you get lots of green leaves. Because as yet we haven't found a market for fruit tree leaves.
So for the soursop.
Sorry?
Soursop.
Soursops.
Soursop leaves.
Yeah. Well, actually, I suppose papaya leaves too.
Oh, yes. Mm-hmm.
Yeah, anyway, but you see, this is an interesting one. See the calcium just jumped right up. Same with the phosphorus, so 123 right up. That is because of all the years of putting on, the previous owners putting on superphosphate. Most of that gets locked up. In fact, over 90% of what gets applied just gets locked up straight away as calcium phosphate or iron phosphate, which they can't use. What's happened here? We've got the biology working. It's unlocked it, made it available. And so what you see here, I didn't, I bought a few things here and there from the compost and stuff in the beginning to get it going, but I didn't buy all this calcium and all this phosphorus. The biology made it available. And the other one for me is using, soil health as the primary tool for dealing with pests and diseases. And we all grow papayas here, and we all know about our favourite little friends, fruit-sucking bugs, and what they do, and how to get rid of them. Well, what I do here, if I see this, you see the damage here. My trouble is I'm away a lot, so I'm not there giving the TLC, go away and come back and see that, I should be watering them better, in the dry season, all that sort of stuff. So, put on compost and water it and give it a bit of TLC and the fruit-sucking bugs go. What you'll find when you start fixing it and have a look, you can actually just pick them off. The plants that put out compounds, we're learning more and more about it, that just slows them down, makes them sick, doesn't kill them. But it means if you've got really good functional biodiversity, you've got lots of little birds and things, they will be able to fly and just pick them off and eat them. Because these things can hardly move, they can't escape their predators. And we're learning more and more about it, in the grower groups, they were fighting for years to keep endosulfan. Oh, it's the only thing we know that can get rid of nut borer or fruit-sucking moth, the last of the DDT groups. Australia was the second last country in the world to ban this poison. India was the last. Even Indonesia did better than us. There's nothing to do, we have to keep this poison, nothing else works. Well, what about good soil health? Changing the system, and that's what I'm trying to say. So I want to actually now talk about the next part of what we call functional biodiversity, agroecology. Just getting rid of this monoculture and getting into bringing in biodiversity instead of things we call weeds. Let's go and start bringing all these other plants that have benefits. So there are lots and lots of little flowering plants you have, and they're native. You actually have it in most systems, or you can introduce them. And what they do is that they are what are called the refuges for our beneficial insects. In nature, there are lots of insects, that I'll use the word insects to cover the whole lot and keep it simple, and that will eat our pests. That's spiders, assassin bugs, all the little parasitic wasps, and so on and so on. Lacewings, and just go on and on and on with all the various species, huge amounts. And many of them, in their lifestyle, have to have what we call host plants. They need nectar and pollen to reproduce. And without it, they can't reproduce. So, you get some farms and they will buy all these beneficials, spend a fortune and release them. They do it every year. They release them, they die because on those farms there is no host plant to complete the life cycle. So what we want to do is bring in all these nice little useful species into our system, all these lovely little flowering plants. Many of them are weeds. And many of our local weeds with small flowers are just perfect because guess what? They already have the native predator there in the system. By letting them go and not spraying them out with Roundup, letting these things go, will build up these populations of these predators. So you see there, that's an example. They're actually, these predators, by the way, they're actually really important pollinators. Up there with bees, the work they do in pollination as well. And so the adults, they get the nectar and the pollen, so they reproduce, and then you'll see the female there, she's actually depositing the eggs on the caterpillar, and then there you actually see the bugs feeding out of it. It's where I know if you saw the movie Alien, where it came from, you know, it's from these predator wasps, that's what it is, and you know, basically, you know, the larva goes in many cases inside and then they bust out. Yeah, that's where Alien came from, but they're not aliens, they actually live here, and they're really important. Just, I remember, actually, in the year, you know, around turn of the century, around the year 2000, I got research from the University of California, Davis, saying that by putting these plants in your system, was in those days the equivalent of spending $30,000 an acre, $30,000 US an acre, on buying beneficial insects. That's around 75,000 Australian a hectare. That is what it is worth by getting the systems right. So, if you can't quite see what, under my trees, I have all these lovely little flowering plants, everybody thinks the weeds. And the whole range of them, but I think it's really nice having those little flowers underneath. But there's all different ways of doing it. You can put them like hedgerows around the fields. That's what they're doing here. You know, just getting a whole range of these plants. In this case, this is a farm in Nebraska, square mile. They just revegetated the whole outskirts of the farm, and that protects the whole farm. You know, just by planting, you know, a whole range of species. Other ways of doing it. Leaving, like I don't mow my whole place anymore. I learnt from, once back from the University of California, Davis, but also Lincoln University in New Zealand, about what we call strip-mowing. We let the grass, the ground cover, grow high so it goes to flowering, and instead of cutting it all down, we mow it in strips and leave these strips what we call refuges. I do it in 3 stages. So, you know, at some point it gets too high, I mow it down, but another area has grown up as a refuge. So I always have a refuge for the beneficial. So here, you have a look at the difference between mowing and split mowing. So this is an example of my place. See, this one's just been cut, and what you'll see, and down there, you know, it's different again, but what you'll see in my place always is different stages of mowing. So I'm always leaving these strips to as homes, refuges for the beneficials. And you can also manage this strategically. For instance, in lychee season, I will, you know, I'll leave these growing right close to the edge of my trees, and then come lychee season, when they're flowering, that's when I get the most pests, I slash it. And that drives the beneficials into my lychee flowers, other flowers, so they then control the pests. I used to, you know, spray organic sprays on it, allowable sprays, you know, like dipel and other things to control it. I haven't used a sprayer on my farm for 15 years now. I lent my sprayer to a neighbour and never got it back.
That's a good thing.
Haven't bothered to ask for it. You know, I haven't had to even use organic sprays by using this And let's look at the science now. This is, I've got this earlier this year, but, you know, research by Florida University showed mangoes with a diverse weed cover produce twice as many fruit. So what I'm trying to get across here now, you know, people like myself and stuff who pioneered it, and we regarded other nutcases, couldn't understand why we had such messy orchards, why we were letting all these weeds go, you know, and let it go to wreck and ruin. Why? Because we noticed we got better and we got more. We now have good evidence-based science showing we do it properly, we get more yield. And in my case, I know I used to be the only organic grower in things like the far north Queensland lychee growers. And farmers are a bit like fishermen when it comes to their yields. They get bigger and bigger. And you know, I used to think, I probably didn't get as good as all the others because I was organic. And then one stage I became president. I had all the figures. I was shocked to see that in terms of yield, I was up there in the highest percentile of growers in our group. And quality, we things our marketing groups, we had to manage quality control. So my quality levels were just as good as any other grower, but my yields were up there with the best.
And your inputs?
Much lower. And the reason why I made more money, because my production costs were a fraction of my colleagues. So, end of the day, that's your net. So, end of the day, I was a very successful farmer. I'm still check my next door neighbour's son now is starting to do the picking and packing. So, you know, the other one for us was, you know, actually more than insects for us, the biggest bugbear are our winged vertebrate friends, the parrots and bats. This is that the only way. We've still got to do a bit of scaring because they can chew through that and get in and under. But as yet, I haven't found a better way to keep them off. So I just want to finish up now and start summarising what I'm talking about. So this is my farm. That's next to my packing shed and everything. And you can see that orangutan trees. What you see here is legume vines growing up the tree. Now, once again, my neighbours just can't believe I let these weeds grow up my trees. You know, it's unheard of. How can you be so neglectful? I took this picture because what I wanted to highlight is we're talking about maximising photosynthesis, maximising every drop of sunlight that goes on our farm and getting leaves to capture it to produce these, you know, molecules of life and what I'll call the multiple ecosystem services. And I've only gone through a few. I'm going to go through heaps and heaps of them. But the reason I wanted to take this is because what you see here is sunlight that my cash crop is not using, is now feeding the cover crop. I'm using that sunlight on those leaves to give me multiple ecosystem services. Now, really important, it does not compete with sunlight. It's below the leaves of my cash crop. Very important. This is a legume. It fixes all my nitrogen. I don't have to buy urea. And like we saw in my soil test, my nitrogen levels are perfect because of this. And also, the soil carbon, those molecules of life, puts in, and so by adding these nutrients, these exudates in, this is not competing with my tree. That's what standard science will say. It is feeding my tree, by feeding the soil microbiome and by giving it nitrogen. We call that green manure. Just when what happens is, it starts now in the dry season. I cut it all down, grow over and take over my trees. Now's the time to do it because, you know, if you cut it now, it's going to stay that way until the rains come. You know, no point doing extra work for nothing. You know, cutting it down, then have to cut it down a few months later, and then a few months after that. Once a year.
Have you noticed much in the water that's required for you?
Yeah, well, I'm about to actually talk about that because I've got that there. It's a really good one, thanks. You can't really see it here, but unfortunately, because it hadn't, maybe I'll see that one there, because you don't have enough contrast. But also here, this has got blue flowers, it's got yellow flowers, all these other little flowers here, and they provide my pest control. Like I said, I'm no longer using organic sprays. I used to market rambutan to Japan. I don't know if anybody's ever salted Japan or been to Japan, but they are the fussiest contributors. Even the way we had to prepare the box, tape it. It wasn't right, they wouldn't accept it because they'd go, oh, if you couldn't take care to present it, what must be inside is rubbish. We're not interested, you know. You offended us right in the beginning. So these fruit that we sent to Japan, because they paid us top dollar, are absolutely perfect. So what I'm talking about is we can get quality and quantity on a commercial level. That's what I was doing. So research conserves water. That's probably another one that I'll talk about, but all those compounds that exudates organic carbon, and they build up to soil organic matter levels. And essentially it works like this: for every 1% increase in soil organic matter, your soils can capture 160,000 litres of water per hectare and store it. So I went from 1% to 6%. So I went from down to have store 160,000 litres per hectare to having a megalitre per hectare stored in my soil. So when I first took over this farm 30 years ago, it was actually my second farm, my first one was in Kuranda, and it was a bit too cold for me for what we bought, and so this farm was actually a customer of mine from the 70s, and then another story, but a lot of the plants on here are mine. But we've been here for 31 years, and but when I took it over, I'd spend the whole dry season irrigating. I haven't turned on my irrigation again for 15 years, and there's no point. It's, I have to redo it, or 15 years of not using it, slashing it up, and all that sort of thing that happens in a normal farm. It's like a bit of. But I suppose what I want to say is that's because by increasing the soil organic matter levels through these systems, you have the ability to capture much more rainfall in the wet season and keep it there for the dry season. And, which is, for me, it's just critical in terms of being able to grow, and also low cost. Irrigating is such an expense, money-wise and time-wise. You spend, when the dry season comes, you spend a whole lot irrigating. You don't get much time to do anything else. And sprinklers break down, lines break, joiners, pumps break, filters, so on and so on. That's farming. If you don't have to do it, you've got much more time for other things. So, I just want to end on this. This is once again our place. And here you can see all the little flowering plants, and what I've got is high species biodiversity. By the way, these are durian trees, and I know the story of these. My wife and I, Julia, we actually collected the seeds of those at Kuala Lumpur in 1977. So some of the oldest and biggest durian trees in Australia, there's rambutans. But what you see here is this wonderful ground cover, and we're maximising solar capture. Instead of having bare soil, this is photosynthesising and providing you with all the ecosystem services. It is not competing for sunlight. Even this bit of giddy grass here, it's not. I'm not going to knock that down. Diversity is a really good thing. I'll slash that down in the dry season, but it can grow now. It's part of the biodiversity. We've got to stop thinking of something like that as a weed, when I slash that down in the dry season, that's all food. Wonderful amount of food for this delivery tree. It's a gift. And here, while it's growing, it's not competing because, like I said, the same amount of organic matter there, okay, we've got double the amount in the soil. And while it's growing, it's feeding. The other thing that's happening here, which is really important, is we get so much rain in the wet season, it runs off. These basically work as silt traps. They protect the soil so we don't get soil erosion. It builds up the soil. It's really important to have this sort of cover during our wet. And while it's growing, it's using that water to produce organic matter to build fertility. So we're actually, we want to use the wet season to our advantage as much as possible and grow as much and let as much grow. And then when we come to this time of year when it's cool and dry, we can cut it down. It'll stay that way until the storms start. So anyway, I just want to end on that. That's my latest book, and I've written up everything about what I said today in this book. So my publisher actually tells me it's one of these bestsellers at the moment. It's in the States. So,
Congratulations.
So Acres USA, just www.acresusa.com if you want it. So I'll end with that and say thank you.
Thank you. That's wonderful.
And happy to answer questions if you